Hey everyone, and welcome to Dr. Abu R10 Academy channel. Today we are going to discuss part 4 and the last part of seminar number 9 for University of Debrecen and the Biostatistics subject. This video is mainly on this epidemiologic investigation. This epidemiologic investigation, the investigation which is related to the spread of the diseases or spread of the viruses like coronavirus. Okay, this is one of the epidemiologic diseases which we need to investigate it. So we have two scenarios. One of the scenarios that we knew the risk from the past, okay, and we have the cases which we have. We have the cases which happened now, and we want to know the risk which was there long time ago, maybe 2-3 years ago. What was the risk? But now we have already the cases, the people who are diseased and who are not diseased. So we have already the facts now, and we want to know what have been happened in the past. Okay, this is called retrospective. Retro means something was in the past, and now I want to investigate it. Okay, and have another approach that I'm here now. I have a risk now, and I want to expect what is going to happen in the future. Okay, so at the present time I know the risk, okay, and I want to investigate or expect what is this epidemiologic investigation. Through this epidemiologic investigation, what's going to happen in the future. This is called prospective. Pro means I'm more active, proactive. Okay, I'm doing something in advance, ahead of the plan. I have a plan to do it after 3 days. I did it today before the deadline. Okay, this is called proactive. I'm more active. Okay, so here I'm trying to do something which will happen in the future. Okay, this is called prospective. Okay, prospective. Okay, so the word proactive or prospective means that I'm going to check something which will happen in the future. Proactive, I'm doing something ahead of schedule. So the word pro itself means in advance. So here prospective means something which will happen in the future, and I want, based on the available risk now, to investigate what's going to be happen, to expect, to guess what's going to happen. This is called pro. Pro, I'll check something which will happen in the future. Retro means something which happened and I'm analyzing it, okay? Which has already been happened, and I got the result, and I want to see what has been happened 2 or 3 years ago. I hope it's clear. I get one slide from the lectures which will be more helpful than this slide, and I put it here, then we can work on it. So this slide from the lecture, as we can see here, I have two cases or two scenarios. One of them called case control or retrospective. Retro means from the past, as I told you. Retro means from the past, and the pro means ahead of schedule, ahead of what will going to happen. Okay, so case control, okay, has the same meaning of retrospective. Or I have prospective or cohort study. Cohort also, we are going to expect what's going to happen in the future. Okay, so here for the retro, in the past I don't know what happened, but now in the present time, okay, I find some healthy people and some diseased people. Okay, like corona, now we have some healthy people and some diseased people. So we can calculate backwards, okay, retrospective, what was the risk 2 months ago or 3 months or 1 year ago. Okay, so we can have two scenarios, the risk present or risk absent, and another case, the risk present or the risk absent. Okay, and with the risk present and absent, what leads to healthy, and with the risk present and the risk absent, what leads to diseased people. The other way is the prospective. Prospective, the present time and the future. So now I don't have the healthy and the diseased people. In the retrospective, I already reached present stage. Okay, and in this present stage, I already knew who are the healthy people and who are the diseased people, because I'm already at the present stage, and I want to calculate the risk which was there. So I'm calculating the risk. But now, if I'm here now, I don't have the cases which will happen in the future. It will happen in the future. So the sick people or diseased people and healthy people will happen in the future. Okay, so I don't have what I have now was only the risk, because the risk happened first, the risk, then after some time the disease will appear. Okay, disease. So if I already have the disease like the retrospective, so what was the risk? But if I'm now in this risk stage like here, the present time, because this is prospective, and now I have only the risk. I don't know what's going to happen in the future. I can expect how many cases will be diseased and how many cases will be healthy in the future. Okay, I hope this is clear about the definition of retrospective or prospective. Retro means I have the present, the actual cases, and I want to check the risk which happened in the past. But if I'm talking about the prospective, I have already the risk now, and I want to see the cases, expect the case which is going to happen in the future. I hope this is clear. So here, back to this seminar slides. Here, prospective or cohort study. Okay, so cohort means it's going to happen in the future. What will happen? Example, what is the relative risk of smoking? So now I have smoking risk. Okay, I could have the risk, I could not have the risk. So the risk may be yes or no, maybe high or low. Okay, so here the relative risk smoking, this is the risk factor which I have currently, because this is cohort will happen in the future. If something will happen in the future, you have now the risk, and the disease will happen in the future, but now you have the risk, because the risk appear first. Since cohort or prospective, I'm expecting something in the future, so the disease will appear in the future. So now I have only the risk. Okay, the relative risk of smoking and development of acute myocardial infarction. Okay, this is a disease for the heart. Okay, the heart muscle. This is a disease. Okay. So as you can see here, first identify a starting point. Is it present? Yes, present. It is cohort. So now I have the risk only. So I start with the risk factor. Is there yes or no? But in future, I'll have the diseases. So now I'm here. This is the present time, okay? I'm here. I have only the risk, yes or no. This is starting point. Which type? It is prospective or retrospective, okay? It is a cohort or it is control case, okay? So it is cohort. Something will happen in future. So what I should have the risk now, and in future I will have the disease. So looking at the graph here, so the risk factor, yes or no. If the risk is yes, I have risk. Maybe in future I have diseased people, maybe I don't have. I have healthy people or disease-free people, okay? So maybe I have diseased or healthy people. If the risk is no, there is no risk now, maybe also I'll have diseased people. Maybe I have healthy people, because there may be some other factor, not only this one which causes this infraction, myocardial infraction. Maybe other factors, not only mandatory that only smoking, okay? So maybe I don't have the risk of smoking, but in future I have the infraction. So it depends. So the two scenarios are available. Whether you have a risk, you may have the disease, may not. If you don't have the risk, also you may have the disease. You may not have the disease. So coming to here, this probability table, I have here the risk factor of smoking, whether yes smoking or no, and the disease, the infraction, whether the people will be free of disease or diseased, yes or no. So maybe I have the risk factor, yes, they are smoking, but diseased, A, this is the frequency, or no, okay? Or maybe they are not smoking, but also diseased will be, I have a number here, and maybe they will not be diseased and they have a number of frequency here, okay? So the total number of the risk factor, okay, the people who under the risk, okay, this is the total number, the frequency of them, A and B. So if I want to assess something against the smoking, I have to get the total number of the smokers, okay, or the risk factor, okay? If I want to get something about non-smokers, so I have to take this number, which is C plus D, this plus the C plus D. The smoker, A plus B, okay? If I want to assess something about the diseased people, so I have to take A plus C, all the number of the people, whether they are smokers, because I'm talking only about diseases, so I have to jump to the disease. The people who are not diseased, I have to jump to B plus D, this B plus D, okay? So from here, I can have A plus B, give me A plus B here. C plus C and D, so give me C plus D. If I consider vertically, it will be plus D. A plus C. The same way we have worked out the other examples, that we can just have these values and add them vertically and add them horizontally. We will get this value, and this will be the grand total for all of them, okay, for the total number. So here, if the question said what is the risk of development of disease, so he's asking about the disease among the subject with risk factor. With risk factor, this is the risk factor, okay? With means yes. So he wants to check the disease among the with risk factor. So the disease will be yes, because disease will be yes. This is the risk factor, yes, and this is the disease. So here it will be the intersection of them, which is A, okay, divided with the risk factor, yes, A divided A plus B. So it will be A divided A plus B. Why? Because A is the risk, has the risk factor and has the disease, okay, divided what he asked me was the risk factor. So the subject was the risk factors. What's the risk factor means? Yes. The total of the yes will be A plus B. In the same way, the disease, okay, he wanted the development of disease among without risk factor. So disease, okay, this is disease, yes, without among with no risk factor, so it will be C. Okay, so this is the one which is the intersection. So he said without risk factor. So the denominator will be without risk factor. What's the total of without risk factor? It will be C plus D. So this is called the absolute risk. Absolute risk here means I take the value of the intersection. Okay, like for this example, he said disease. So I check disease. Yes. Okay. With the risk factor. So this is the disease, yes, with risk factor. So this is the line for risk factor. So this is the point A divided the total, because he wants only with the risk factor. So the total of the risk factor. So it will be A divided A plus B. If he said disease among subject without, so disease here without, it will be C, okay, divided C plus D, which is the total of without risk factor. Sometimes he asks me to get the relative risk between the two cases, disease with the risk factor to the disease without risk factor. So it's called the relative. So this one relative to this one. Is it 0.1 time, equal, 2 times, whatever? So it's called the relative. Relative something relative to another thing. So it could be the combined question. So here it will be the disease among subjects with risk factor divided the disease of among subject without. So the relative risk called RR, the ratio of the risk of developing a disease among the subject with risk factor 2. So identify here, this is the first part, 1 to 1. So something in the denominator divided something in the denominator. So the denominator will be with, which we have already calculated, A divided A plus B, A divided A plus B. This is the denominator, okay, with the risk factor, this one. Divided without, it will be C divided C plus D. So this will be the RR, the relative, okay. I can get A plus B because this is the denominator, I can put it down, and the denominator of the denominator it will go up, other way around. So it will be A times C plus D divided C multiply A plus B. In this example, it says that in a study, the correlation between psychosis and the cannabis use. Okay, psychosis, this is one of the mental disease which come to the mental and make the people unstable. Okay, psychosis and the cannabis use. Cannabis is the type of leaves, types of drug leaves. Okay, which people are putting in cigarettes and smoking it. Okay, so. Like the one which they have in Afghanistan and Yemen and places, okay? So, is there any relation between smoking this type of cannabis leaves, putting them in a cigarette, make cigarette with them, and smoking them, and the psychosis, or no? Which is the problem which happened in the minds, okay? Mental problem happened to the people. This was investigated, and a random sample of 2,447, okay? Normal adolescents means because they cannot try or test this cannabis smoking on people under age. Okay, these people has to be adults. Okay, this experiment has been done for normal adolescents. Okay, the people who are more than 18 years old was taken, and the questions them about their use of cannabis. Okay, they followed them up to 4 years. Okay, so it's long duration, and then ask about. So here they started with the risk, investigate the risk, and then after 4 years later, which is supposed to be in the future for them, okay, and then ask them about the symptoms, and the results are summarized in the blue table. Okay, so psychosis here, whether they have the psychosis or no, this disease, the mental disease, yes or no, and whether they are using the cannabis, smoking the cannabis, yes or no. Okay, so we can see the numbers here that okay, some of the people, okay, they have this mental problem, but 82 are smoking of them cannabis, and 342 are not smoking. Some people, they don't have the disease, but 238 of them are smoking the cannabis, although they're smoking, but they don't have the disease. And 1,775 of them, they are not smoking. Okay, so here the question is, calculate the relative risk of psychosis for cannabis smokers. So here, in order to answer this question, we need to understand what question is asking about. So the question here asks about relative risk. Relative risk means that we will get one risk divided another risk. Okay, so the numerator will be two numbers divided each other, which is one risk, fraction, and the denominator will be fraction. If we looked here at the previous page, let us clear this one before going there. Here, if we looked here, we had the risk, yes or no, and disease, yes or no, and then we say that the risk of development of disease among the subject with the risk factor is A divided A plus B. So why in this case we said A plus AB? Why you didn't say A divided A plus C? Why we said A divided A plus B? And also in this case we said C divided C plus D. We did not say C divided A plus C. The reason that here in the question it says the risk of the disease among this with the risk factor. So he's talking about the risk disease with risk factor. So where is the intersection? So first thing we have to get the numerator. Numerator will be the intersection between disease and with risk factor. So here disease, yes, with risk factor, yes, so it will be A. So I know the first one, which is the numerator. Okay, so coming to the denominator. Denominator will be, just let us be clear this one as well. Okay, so the denominator will be the second part. So, okay, disease among the subject for, or the disease among the subject with the risk factor. Okay, so here first thing is talk about this. So the only use of having disease just to get the intersection of the disease and the risk factor. Okay, so disease and the risk, disease and the risk, we get the numerator. Then with the risk factor, so the main point you want to calculate this risk with respect to is the risk factor. With the risk means yes, risk factor is yes. Without risk factor means the risk factor no. So with the risk factor means yes, risk factor. Where is the yes risk factor? This is the risk factor and this is yes. So we'll get the total of it. So it will be A divided A plus B. Okay. So coming to the second one, the risk of the disease, also disease without risk factor. Okay, so let us clear this one so we're not confused. So here, okay, disease without risk factor. So here disease, okay, without, it means no risk factor. Okay, so this will be the denominator, which will be C. Okay, dividing whom? Without risk factor. Okay, without risk factor. So what is without? This is risk factor without risk factor. So the sum of the risk factor, C plus D. it is not mandatory that it will go always horizontal. Okay, we have to find which one we are calculating with respect to what or for what. Okay, the last one always comes the last one. Okay, so this will be the total which will be put in the denominator. Okay, so when we reflected the same concept on the example which we have in this page, so first of all we have to find the relative. We know that the relative risk means something divided something. So what are the two things? What's the first thing which will be in the denominator and the second thing? So the first thing which he's looking for, he's looking to the relative risk of psychosis for cannabis. So the first one will be psychosis for cannabis. Okay, and the other scenario will be opposite, because in all the cases he's checking or looking for psychosis. Okay, for cannabis. So it could be with cannabis or without cannabis. The same way we have here, with or without. Okay, here with or without. So the same concept will be applied here. So also the second one will be psychosis for not using cannabis. Okay, cannabis. Okay, so first time we'll get this fraction for cannabis and the other one for not cannabis. Okay, so for cannabis, it will be what is looking for cannabis. It will be look for psychosis for cannabis. So psychosis for cannabis. So the intersection, the denominator will be the intersection. Psychosis, where is it? This is psychosis. Okay, yes, psychosis means yes, not, it's not no. It is not psychosis, it is yes, psychosis. So psychosis, yes, and with cannabis. Okay, cannabis, yes also. So it will be 82. Okay, divided what is the one which is looking for cannabis. So cannabis, yes. Okay, cannabis, yes. The total of cannabis, yes, is 320. So for not cannabis or cannabis, no cannabis equals, okay, so the same thing here, psychosis, not cannabis. So psychosis, yes, but not cannabis, which will be this one. In this case, this will be our intersection. Okay, let us clear this one to make it clear. So in the second scenario here, it will be psychosis, which is yes, with the not cannabis no. So it will be 342 divided the total of what? Not cannabis. So not cannabis, the total is 2,117. 2,117. So this one will be equal 0.162 and this one will be equaling 0.256. So you want to get the relative risk of psychosis speaker to not psychosis, because the relative means something to the opposite. So relative risk of psychosis for cannabis divided the psychosis for not cannabis, because you want to check the impact or the effect of cannabis. If someone is smoking cannabis, what will have the effect? So if he's smoking cannabis, he will have this percentage, okay, which will have this amount, which is 0.256 for cannabis, 0.256. If he's not smoking cannabis, he will have this probability, which is 0.6. So what is the relative? How much or how many times the smoker of cannabis is more risky than the non-cannabis? So we have to divide them. So here it will be the deviation of, the relative will be the division of psychosis for cannabis divided psychosis for not cannabis. So it will be equal to 0.256 for cannabis divided 0.162 for non-cannabis, which equal 1.58. Okay, this means that it is 158%. So the probability of getting psychosis for the people who's getting cannabis is 158% of non-cannabis, because this is in the denominator. So here this one is bigger. Okay, 0.256 is bigger than 0.162. So the people who are getting the cannabis, they are subject or they are exposed to psychosis 58% more than the one who is not taking it, because here it is 158. So the difference is 58%. So they are 58% higher than, the risk is higher than. So from here we can get the conclusion that using the cannabis, the drug, it will increase the possibility or the probability of getting psychosis disease by 58%, which is written here. The risk of the psychosis, okay, for non-cannabis, okay, it will be this one. This is for non-cannabis. It will be the risk will be 0.162. While the risk for cannabis, the people who are taking it for cannabis, it will be more, 0.256. The one who's taking the cannabis, okay, or smoking the cannabis. Thus, the relative risk of psychosis for cannabis smoker is the one who is taking cannabis to the one which is not taking, which is 1.58, or the risk is increased by 58% in case of the people who start smoking or the people smoking cannabis. Okay, I hope this point is clear. So this was the prospective, okay, prospective, something which we know the risk now and we want to know what's going to happen in future, okay? So we estimated what's going to happen for these people who are smoking cannabis, because here they estimated they assessed the risk and then they can, after 4 years, okay, followed them up to 4 years. So they put the risk first and then they follow up to 4 years later, which for them it was the future, okay? So that's why it was prospective. Now we'll come to the retrospective. So here in this retrospective case, okay, retrospective study, or the called case control, okay. Retrospective, as we said, that we having the real disease available, number of cases who had the disease, and we want to check in the past. Retrospective, what was the risk in the past, okay? If this is the case, what happened earlier, okay? So we were not, if you remember in the prospective, we were using, for example, here we're using the psychosis, okay? The people psychosis, yes, was non-cannabis, okay? Psychosis, yes, was non-cannabis. So 342 divided the total number of the last one, which is non-cannabis, okay? So the intersection divided the total. But here in the retrospective, we use something called odds for each individual. So this is odd, this is odd, this is odd, this is odd. So in the retrospective case, okay, we have something called odds, okay? So we are calculating the ratio of the odds, okay? The ratio of so the ratio here, not between this one and the total, or between B and the total, or A and the total of the row, or C and total of the row. No, it will be between the odds themselves. So in the retrospective, the ratio will be between A and C, or C and A, B and D and B, between these 4 figures together, okay? So the intersection will be put in the denominator. For example, I said risk factor, okay? Risk factor, or smoking with disease. So smoking with disease, smoking means yes, with disease also yes, so it will be A. If I said A, so it will be the complementary of it, yes, so I have to take no, it will be A divided C, okay? So if I say how many odds I can find, okay, in the smokers with present disease, so I get the intersection A, and will be divided what I'm looking for, the last one of the present disease, This is the last thing. So this will be, I have to go in this column. Because this column will be the presence, okay, the present case. So I have to go in this column. I think if I give example, it will be more clear. So better, let me give an example from the lecture slides, better than the seminar, because seminar also is more summarized. I need to get more elaboration, more details. So by looking at this example here, if I want to get the relative frequency, we said the relative frequency here, we have to look at relative frequency of risk positive. Okay, so he's looking for risk positive disease with risk positive. So disease with risk positive, it will be 30. Okay, so what he's looking for, he's looking for which one? He's looking for risk positive. So I have to get the sum of the risk positive. What is the sum of the risk positive? It will be 330. Okay, 330. So this will be the relative risk. Okay, so what if I want to check the odd ratio? If I want to calculate here the odd, okay, for relative frequency of disease and risk positive also, so I have to take the intersection between disease and risk positive. Okay, disease and risk positive. So disease will be this one, risk positive, it will be also 30. Okay, so this is RR, and here will be the odd ratio, OR. Okay, it will be 30 divided what? It is 30 divided what I'm looking for. I'm looking about the frequency, the risk positive. So I have taken the risk positive has two values. The risk positive has this value and this value on the same line. Okay, only two values. This is the total. We will not consider the total. So if the risk is positive, I have only two values. If the risk is negative, I have these two values. So he said risk positive. Okay, risk positive. So I have these two. I have already taken the total of them in the case of the relative frequency. This one divided the sum of this risk positive, which was 330. So I get 30 divided 360. This was for RR. What about if I want to calculate the odd ratio? Odd ratio will be the relative frequency, okay, which is 30. I put here the denominator 30. What about the denominator here? What if the risk is not positive? So here the risk is positive, and the middle will be the risk is not positive. So I have to use only the odds which I have here. So the risk is positive divided the risk is not positive, which will be 10. So 30 over 10. Here this was an example, and they have given the relative frequency and they calculated it. They have got it 3.73, and by the odd, using the odd ratio, it was 4. And in the other case, okay, they have calculated also the relative, and the relative was 2.5, and the odd ratio remains the same. So here they arrived to the conclusion because the sample was small. So here look at the sample of the disease. Sample was 30 and 10. Here the sample times by 10. Okay, 10 times larger. So it was 300 instead of 30, and 100 instead of 10. So it was multiplied by 10. So when he increased the sample and the disease people, the negative disease, okay, it remains the same. Okay, 300 remains 300, 400 remains 400, and 700 remains 700. So the negative disease or absence of disease remained the same, but disease, the number increased. So he found, or he noticed that the RR, the relative frequency, it changed largely from 3.73 to 2.5, but the OR remains the same. So he reached a conclusion that in case of we are calculating something which is in the past, okay, something happened in the past, the risk in the past, so it's better to use the odd. Okay, better to use the odd ratio. It says the OR is unchanged compared to the example above. In case of control study, control means I have the control now. I knew who are the diseased people and who are the healthy people. Okay, controlled. The OR is a probability statistic. Okay, the RR depend on the size of the disease population sample. So if I have the size increased here, see if the size increased, the RR it changed, but the OR did not impacted by the change in the number of the population. Another example to make it more clear, here we have, he's calculating the OR in two different conditions. Okay, so he said here in the first example here, how many times the odds of findings a risk exposed person. Okay, so here I have the risk exposed person. Okay, a risk exposed person in a diseased population. So he want to find it in the diseased population is larger than the odds of finding of a risk factor exposed person in the healthy population. So we look at the first part of it. Okay, OR, it is like RR. It is two fractions. Okay, so one fraction here, one fraction in the denominator divided another fraction in the denominator. So we have to find the first fraction and the second fraction and then divided them. This was RR. And the same thing also for OR. Only the principle or the concept which figure to be divided by which figure, this will be the only difference between them. So by reading this example, let us take it part by part. How many times the odd number of the finding of risk factor exposed person in the disease. So it is risk factors and disease. So risk factor here and disease. So it will be A. Okay. Divided in the diseased population. Where is the diseased population? This is the diseased person. Okay, this is the diseased population. So I have already taken A. So what is the balanced one in this one? It will be C. So it will be A divided C. Okay. So the second part of it will be R larger than the odds of finding risk factors exposed person in a healthy. So risk factors healthy. This is the risk factor and this is healthy. So it will be B. B divided what? He said in the healthy population. In the healthy population. So we have to go to in the healthy population. This is the healthy population. I have B and D. I have already used B in the denominator, so I'll use D in the denominator. That's it. Then I will divide A divided C, this fraction, divided B divided B, B divided B. So D will go up and DC will go down, so it will be AD times BC. Some people are saying, okay, it is a cross multiplication from the left to right, divided from the left to right, up, down, and from the left to right, down, up. Okay, so it's a cross multiplication. AD divided AB. Sorry, AD divided BC. AD divided BC. It's not good. Let's just delete this one. Okay, it is AB, AD, A times D, AD divided BC or CB. Okay, but it's better to have these details so you'll have full and detailed understand. You'll make sure that your answer is correct. If we calculate it in a different way, say here he said in the other another interpretation, another way of interpretation, how many times? Actually, I'm just giving this example from the lectures to show you how we can. It depends on the scenario how we can get these values. Okay, for OR. So this is a different scenario. How many times the odds of finding diseased person? In this case, he was saying of finding a risk factor exposed person. So he talk about the risk factor first, and then in the diseased population. In the diseased population. That's why in the disease, this was my denominator always. When you check the value here, I have to check the other value in this line. Okay, in the population. I was not taking A and B horizontally. I was taking it always vertically because he said in the diseased population. This is the diseased population. I have taken one, so next time I take the other one in the denominator. Okay, so let us look at this example and understand what is the difference between them. So here he said in another example, how many times the odds of finding diseased person in a risk factor exposed. So I need diseased. This is the diseased. Okay, and this is the risk factor, which will be A. So the first one here will be A. What about the denominator? He said in the risk factor exposed population. Which one is the risk factor exposed? This is the X factor exposed. This is the risk factor exposed population, this one. So I have already taken A from here. So the only one remaining is B. Again, just let me clear it and draw it. So here, he said the finding of the diseased person with the risk, which is A, diseased, risk with the disease, so it is A, We have done with this one already. To the, so A is already selected. Let me just undo. Okay. So we have selected A in the first time. So the second step in the, so this will be the denominator in the risk factor exposed population. Which one? This is the risk factor exposed. So I have already taken A. The only one remaining will be, so it will be A divided B. The second one are larger than the odds of finding of diseased person. Okay, diseased person also. And the risk factor negative population. Risk factor negative population. Sorry. So what he has said here, he has said here diseased person. Diseased person. This is the diseased person. And the risk factor negative. So it will be C. Okay, C. I have already chosen C. So what he said in the risk factor negative. So this is the risk factor negative. I have only C and D. So the remaining will be D. So the odd only we are picking or selecting within the odds, within this odds, A, B, C, D only. We are not taking the totals, okay? Between the odds only, okay? And this is the way we check the last one. This will be the denominator, okay? And the denominator will be the intersection of them. I hope this example make it clear. So we'll back to the seminar slide. So going to the example here, which was in the seminar, which will clarify more and more, and our focus will be on the seminar itself. So here in this problem, it says that in a retrospective study, so he gave us the key, retrospective. This means that we are going to use the odds. We are not going to use the relative ratio, okay? We are going to use the odd ratio, okay? Or the relative risk. We are going to use the odd ratio. The retrospective, sometimes they call it control, okay? Because the retrospective, we have the case already happened, which is already controlled, and then, or the negative part, the negative assumption or hypothesis of the experiment, they're calling it controlled, okay? So in the retrospective study, the role of the smoking in pancreatic cancer, okay? 50 patients, okay? The study of the role of smoking in cancer, in pancreatic cancer, 50 patients with cancer are identified. So the total number is 50, and it is retrospective. And it is determined that 10 out of 50, 10 out of them were exposed to the risk of smoking. So here I'm talking about people with okay, so here if you can see that I have the risk factor, and the risk factor here. So in the risk factor here, we have the risk factor of smoking and non-smoking. So the question says that risk factor in cancer patient, okay? So this is the intersection. Risk factor means smoking, positive. We can say risk positive is smoking positive. So risk factor means the risk is positive, okay? Risk factor in cancer patient. So here we will have the first one is 10. The first odd will be 10. Okay? 10 over in what? In cancer patient. So we have already used the 10, and this is the cancer patient who was cancer positive. So what is the other number? Will be 40. So 10 divided 40. So this is the first odds. Okay? So this is called the odds of smoking, which has risk factor or smoking. You can call it whatever you want, smoking, if you'd like, in the cancer patient, okay? So the odds of smoking in the cancer patient. So smoking and the cancer, the intersection between them, smoking and the cancer, 10, divided in the patient, okay, of the cancer. So this in the patient of cancer, these are the patient of cancer. So the second one, because we have already taken this one, it will be the second one. The second odd will be the risk factor or smoking in the control group. Okay, the odds of smoking in the control group. So the odds of smoking or the risk factor smoking in the control group, it will be 2 divided, we have taken 2 in which one? Control group. Which control group means C negative, cancer negative. So what is the other number of the odds? 48. So 2 divided 48. Okay, so if I want to get the ratio, the odd ratio, it will be 10 divided 40, this one, divided 2 divided 48. It will give me 6. Okay, so the odd ratio in this case will be 6. In this slide, we are going to talk about the Kaplan-Meier curve and determination of the average survivor. Okay, this is part of the analysis of survivor curves. I also preferred here to get this slide from the lecture to make it clear, because I feel that the seminar is not so clear in this area. So here it talks about that in the clinical investigation, it is common to analyze the time of occurrence of events. Okay, time of occurrence of event like reoccurrence of kidney rejection, occurrence of death, occurrence of diseases. Okay, reoccurrence of the diseases. So all these things we need to, from time to time, to calculate or to analyze the occurrence of them. So here it is important also to analyze the effect or the impact of the treatment on the mean survivor. Okay, so if you have a person and he got a treatment and he survived after getting this medicine or medication for 3 months or 2 months or 5 months, then he passed away. So some other people take the treatment and just will pass away after 1 week or 3 days or 2 days, some of them after 1 year. So what is the mean time of survivor for this treatment or this such type of treatment? How long they stayed? In order to calculate this, I have to know how long they have stayed after taking the medicine. This means that these people already passed away, because if they're still alive, this means that I cannot say their survival time is 3 months. Maybe they will still alive for 5 years more. So they have to be passed away, took the treatment and passed away, so I can calculate the period between giving the treatment and until the time they passed away, so I can get the time of survival, how long they survive. But if they are still alive, this means we cannot calculate their survival because they're still alive, it's still counting. Okay, so here in this example we say that it's important to analyze the effect of the treatment on the mean survivor. Okay, the second thing here, which we call the censored observation, the patient whose survivor time is unknown. In the example, sometimes we don't know their survivor time. We lost their record, the file lost or whatever. So lost in the investigation, or forgot to make the investigation about him, or he moved to another place, from one country to another country. We lost the track of him, or he is still alive at the end of the investigation. Okay, so here you find zeros in the graph, the survivor time graph. Okay, so these people, maybe they are still still alive, we cannot say. So we have 50 people, for example, here still alive, 70 people, 20 people. So we don't know, because they're still alive, we don't know how long they will survive. They're still alive, or we lost their investigation, or they moved from one place to another place. Okay, so here we can calculate the mean, okay, of the survivor, or the median of the survivor. So the first way here is to calculate the mean. The mean calculation equals the total sum, the sum of the time, survivor time divided the n. So this is the mean. The time mean t bar equals the sum of the survivor time divided the n. Okay, but this is actually, it is not accurate, as we see here in the example. N has some people, okay, n has some people who are who still survive, they did not die yet. Okay, so we'll find them 0. Okay, so they are counted, n is counted. Okay, n counted, but their time is not counted because time is showing 0 here. Okay, so the sum of the survival time, they are counted as 0, But in the division, we divided by n. We counted them in the division. Maybe there are 100 or 700 or 230 people, 150 people. We don't know how many they are, but we don't have survivor time for them. Their survivor time is 0. But the n, they are counted in the n. So the mean in this case, it will not be accurate. Okay? He said here, as per the example, because the survivor time of some patient is unknown. We don't know the survivor time, 0. So if we add 0, 0, 0, you'll end up with 0. 15 plus 0, it will be 0. So these people, they don't have the record, okay? So we have some people with values, like these people, and we have some other people without value. So he has given here in this example, which we have here down, in this example, okay? We have some people in this example with 0 survivor time, but they are counted as numbers. In the investigation blue had been stopped at 15 months. So here the mean is 15 months. If the investigation blue has been stopped at 15 months, the survival time of the patient living longer, who is living, so here they consider up to 15 months only. So after 15 months, the experiment finish, okay? So they did not count for the people. I still have groups of people here, 1 group, 2 groups, 3 groups, 4, 5 groups of people. They're still alive, okay? But we still stop the counting here. So if we stop the counting here, we will lose these people. Our results will not be accurate, will not be appropriate, okay? For the patient who lived longer, and it's unknown to us for how long they will live. That's why we put 0 here, but we did not put 0, so our answer will not be accurate. The median survival. Median, as we said earlier, that just will rank the people, like for example 1, 3, 4, 7, 9, just to put them in the order, and they will take the middle one, okay? So the median survival, the time will take until half of the patient survive. Until half of the patient survive, okay? So there are there are 2 ways, which is the mean and the median. So here we have taken here in this slide the characteristics of the mean survivor, okay? Usually we calculate or we use the mean, okay, which is the sum of the survivor times divided in. But as we mentioned in the previous slide, it is not appropriate because the survivor time of some patient is not known. The second thing will be the median of the survivor, and we go until the time of the half of the patient, okay? The half of the frequency. I have to list down the people, 1, 3, 7, and so on, 9, 11, the patient, and select the median one, okay? So the median here, we have to go until the half of the patient. If I have 29 people, okay, 29 people, so I have to check 29 plus 1 divided 2 equal 15. So I have to check the people here. Number 15, okay, this will be, I have to check what is the survivor time, and this will be my median. So here, sometimes we have the relative frequency. Relative frequency, for example, I have in this category 25 out of 100, okay, so it will be 0.25. In other place I have 1 over 100, it will be 0.01, and so on. So we have to present them up to 100%. So this is 100% of the frequency. This is frequency, the number of people. Remember, I have in this category 25 people, other categories 13 people, other categories 27 people, 47 people, and so on. So it's called frequency. Relative frequency, we divide the number of people to the total number. Okay, so the n of this category divided by the n total. This is called the relative frequency, okay? Total, okay? This is called the relative frequency. This is the relative frequency. Frequency, if I have a table like this, okay? I think we have taken it in one of the previous videos. So if we can say, for example, for category X, category Y, category Z, and total. So we have 25, we have 50, we have 25. So here, in category X, I have 25, category Y I have 50, category Z I have 25, total is 100. But here I have, this is called frequency. How many people under each category, under each class. But relative frequency, the percentage, so 25 divided the total, which is 100, so here 0.25. Here 0.5. 50 divided 100. Here 25 divided, so 0.25. So it's called the relative frequency. The sum of these should be adding up to 100%, okay, or 1. So that's why you find here the relative frequency if you check here, the relative frequency is up to 1. Okay, from 0 to 1. Okay, the total comment. So if I want to get the median, okay, the median means half the way, half the number of the population. So I go to the relative frequency 50% or 0.5. So I go here up and at 0.5. No, it's not writing. Okay, so let us verify here. So it will be 0.5 here, and draw horizontal line until I meet the graph, and then go down and get the time. So the time from here, it looks like 7 or something. So it looks like the survival time here will be 7. Okay, 7 months. Okay, this will be the survival time. Some cases we just need to fine tune this curve. Instead of having it step, we can fine tune the curve. Okay, because here you can go 1.1 very slight point here. If you go here, you will get one reading which is very high, 0.4. If you go a little bit slightly very closer to it, okay, you will get 0.3. So better to have it as a curve. Okay, so in case if it's a curve, it will give more accurate result or more accurate data. This example is a straightforward example. It says that in Kaplan-Meier curve, blue shows the survival of cancer patient as a function of time. So here, the fraction of the surviving of the patient, okay? The fraction of the surviving from 0 up to 100 is like relative frequency. And here, the median survival time is 12 months. Okay? So this is the answer actually, okay? So based on the Kaplan-Meier curve estimate, the median survival time, find the median survival time. Based on the Kaplan-Meier curve, estimate, because it's a curve, you cannot get it exactly, estimate the median number, okay? So the median number here will be, I go to at 50%, so here 0 and here 1, so midway 0.5 or 50%, draw a line, okay, and go vertically using the triangle. If you have a triangle, just to put it, a triangle in the exam, just to put it, or by using the ruler, if you have this graph paper in the exam, if you have the graph paper. Okay, so it will be easy. So go down vertically, so here you find 12. So here the median survival time is 12. This one which he requested. So I think it is very clear, such case. There are some other some few points here it's mentioned in the lecture, but it's not repeated here. That's good. This was related to the chi test, that the sample should not be less than 30%, and if it is less than in one of the categories in the table, in the contingency table, should not be less than 5 numbers. The frequency of the people here should not be less than 5 numbers, and the total number should not be less than 30, the sample which you are picking. So you can look at them in the lecture slide. It's very clear there, in case if you want to get some more information or more clarity on them. By here we end up with the last slide of the seminar 9, and I wish you all the best, and I hope that you fully understood and digest the course. Thank you very much.